Okay, so this video is going to deal with finding the area under a curve of a parabola. So the function for this parabola is negative 2x squared plus 5x plus 3. And so it wants you to find the area of the shaded area on like the graph. And so using 6 rectangles. And this is only going to be like an estimate because for these rectangles, there's going to be tiny gaps in between them, so it's not going to be 100% accurate. So in order to do this, you find the sum of parentheses 2 times parentheses 2 6k parentheses squared plus 5 times parentheses 2 6k and then plus 3, and then that whole entire thing times 2 over 6. And that part that's in the parentheses accounts for the height of the rectangles, and then the 2 divided by 6 accounts for the width. And you need the 2/6 in the parentheses to account for the length of the width, and then yeah, basically. And so after plugging this into my calculator, I found the area to equal about 10.93 units squared. Now, in order to find the actual area, it's also the same as finding the limit as n continues to infinity, because what this is basically doing is you're putting infinitely as many boxes underneath that curve, and that's going to eventually lead you to the actual area because there will be no gaps. And so in order to do that is, in the previous equation, any part that had 6 in it is going to be replaced with n, because that 6 accounted for the 6 rectangles, and since this one is infinitely as many, you have to put n in. And so what I did is, so I had the sum of parentheses negative 2 times 2 over n k squared plus 5 times 2n over times k plus 3, and all that times 2n. And so what I did is I just simplified it as far as I can. And so the simplest form is on the very bottom. So it's the sum of parentheses negative 16k squared over n cubed plus 20k over n squared plus 6 over n. So the next step in this is you're going to substitute the sigma for k squared for n times parentheses n plus 1 times 2n plus 1 over 6, and then you're going to replace the sigma k for n times parentheses n plus 1 over 2, and you're going to replace the sigma 1 for n. So what this looks like is you're going to have negative 16 times parentheses n plus 1 parentheses 2n plus 1 over 6, all of that divided by n cubed, and then you're going to have 20 times parentheses n times parentheses n plus 1 divided by 2, and all of that over n squared plus 6. So lastly, I just copied the equation that was found on the previous slide. And so since the coefficients on the top and the bottom of each of the fractions is to the same power, and the first one they're both n cubed, the second one they're both n squared, and then technically the next one they're both n, you can divide the coefficients of each fraction and then add them together to get the actual area. So you have to do, for the first one, you have to do negative 16 times 2 to make sure you account for that 2 that's kind of hiding out in there, divided by 6, and so and then you have to add 20 divided by 2, and then you have to add 6 to that. And so you get the real area under the curve to equal 10 2/3 units squared.